Hi, everyone. Thank you for attending the 3 sessions on hierarchical linear models. I just wanted to bring to your attention the statistic called the intraclass correlational coefficient. What this does is it helps you as a researcher or as a statistician have a measure of how much the clustering in your data is contributing to the variance in your model. So if you remember, your variance plays a key role in determining your standard errors, which are used to determine your p-values and which help you understand whether your model or your variables are statistically significant. So they play a role in your conclusions that you make with your study. Now, you want to know whether that clustering between or within your clusters is playing an impact on the decision that you're going to make when you model your data. And so to do this, statisticians calculate the intra-class correlational coefficient. It's quite a mouthful, where they look at the variance between between the clusters, and they divide that by the total variance in the model, which is the between cluster variance plus the within cluster variance. And what you get, the ICC is always a positive value. It falls between 0 and 1. And what it shows is the higher the value, the greater the clustering. Okay, and let us look at an example. But before we move on from this slide, we're saying there's no agreed threshold for how great an ICC should be that it would bias our estimates. It would bias our estimates. But however, it gives you a sense to what extent the clustering may be affecting your model. So let's look at an example that would help us understand. So we have this study, if you remember, we did this in the second session where we looked at children across Africa in different countries. So the clusters were the countries, and we looked at their hemoglobin levels. And you can see here that we have the hemoglobin on average in the fixed estimate for an African child, an average of 10. And then we have the random effects here by country, where you have your country, and then depending on what country, there would be an additional hemoglobin, which could also be subtraction. And when you look at the between country cluster, you have variance between country cluster variance. You have a variance of 0.2 right here. And when you look at the total variance for between and within, you have your between, of course, of 0.2, but your within cluster of 2.6. And this gives you an ICC of 0.07. And so what this makes you realize, let's start with this within cluster of 2.6. That is the variance in the sample, or the variance in your results within a country is very large compared with the variance that's happening from country to country. And this makes your ICC low. And so this gives you a sense, a clinician, a researcher, a statistician could say, well, maybe we did not need to do a multi-level linear model because of how the intra-class correlation is just so low compared, when you compare the between and the total is so low that it really would not have mattered. And so that's one way that you can judge this. But as I said in one of the sessions, it's always better to do the best practice. And so even though we arrive at this conclusion that maybe it would not have been a good idea, because the data was clustered, it was important that we look at that data and conduct this study using a hierarchical linear model. So just to summarize that the ICC gives you a sense of how the clustering in your data may be impacting the results that you have uh, if you're if you're within if if you're within and between a cluster variances are large or smaller relative to one another. So thank you very much, and I hope to see you in the next class.